There are four basic elements to a computer. Input units feed information to the computer as electrical pulses, which are translated to the zeros and ones. Typical input units include keyboards, mice, and barcode readers. Output units provide the information requested of the computer. They include monitors and printers. In semiconductor memory, there are two principal types of circuits. Random access memory stores data that can be easily erased or updated.
Mom, come here.
Known as volatile memory, the data is stored only as long as the current stays on.
Oh,
Come on, Mommy, I want to show you something.
all right.
Read-only memory, known as non-volatile memory, stores information even when the current is off. This memory contains permanent programmed instructions that enable the microprocessor to start. The processor, also known as the central processing unit, is considered the brain of the computer. Millions of program instructions are carried out in seconds, synchronized by a master clock. Inside of this computer, we find a microprocessor containing over 1 million transistors. The speed of a signal traveling through these transistors affects the computer's performance. In an ideal environment where there is no resistance, an electrical signal would travel at the speed of light. In a chip, however, resistance from the conductive paths between transistors and the capacitance of wires and transistors slows the signal speed. Most of the speed is lost, though, on the circuit board, where the signal faces an obstacle course of long transmission lines, inhibiting materials, and the chip's packaging. As the signal travels from one chip to another, it encounters increased capacitance in the large surface areas of the pads, the solder, and the metal leg of the packaging. The most difficult are the thin wire bonds, which resist the flow of current. As circuit technology has evolved, we've seen an increase in the bits of data on which a chip or microprocessor can operate. This increased the computational power, but required more transistors and higher clock speeds. These increases have led to the high-speed chips used in today's powerful systems. With these fast chips, the delay on the board can cause an information bottleneck in high-performance computers. To overcome these problems, this high-end computer uses multi-chip technology to enhance performance. From the back, we see one example of a planar module with the outline of 16 multi-chip units, or MCUs, working together. Each one of these units contains the logic, formally mounted on several much larger printed circuit boards. High-powered chips are packed into these small units